Show some more of their remaining problems. I believe we did problems 1 through 10. I'll try to get through as many as I can right now. So I'm going to do problem number 11. 11 is 5x squared minus 45x plus 100 equals 0. So this one has you solve it. So that means you're going to factor it and then go that one step further and solve it. Remember, when you factor it, you're just getting its two factored pieces. But when you're solving it, you're taking that equal to 0 and you're solving that for x. So for this one, I'm going to factor out a 5 out of all these numbers and then reverse distribute, which means that has to be x squared minus 9x plus 20 equals 0. And then I'm just going to factor what I have left right there. So I have negative 9 and positive 20. And if I break up 20 into all its numbers, I can see it's going to be negative 4 and negative 5. Those two numbers are going to work. Let me zoom this in a little bit. So if I put those numbers in there with that 5, I have x minus 4 and x minus 5. Don't worry about worrying about this right here. Solve these pieces for x. So x minus 4 equals 0. X minus 5 equals 0. Again, remember, this is factored. If it says factor, they won't have that 0 in there. If they say solve, it will have that equal to 0. So then you take these two pieces and you solve them for x, adding 4 to both sides and then adding 5 to both sides for that one. So the answer is x is 4 and x is 5. Number 12. 12 has you solve it by factoring. So you have x to the third plus 2x squared minus x minus 2 equals 0. So I'm going to factor this by grouping. So this first one, I'm going to take out x squared out of it, and that will give me x plus 2. The second one's a little trickier. I'm going to take out a negative 1 out of there, and that will have to be x plus 2 in there for me to get negative x positive 2. Negative 2. So taking out a negative 1 in there makes that have to be x to distribute and get negative x, and positive 2 to distribute to get that negative 2 up there. And now you bring these two pieces together. So you have x squared minus 1 and x plus 2. And now this is a little trickier because this is one of those special cases. X squared minus a number that's square rootable. So that ends up being x plus 1 and x minus 1. So this one you're going to have 3 separate answers. So I set up x plus 1 equal to 0, x minus 1 equal to 0, x plus 2 equal to 0. Take away 1 both sides, gives me one answer, which is negative 1. Add 1 to both sides, gives me x equals positive 1. And then take away 2 both sides, gives me x equals negative 2. Those are my answers for number 12. Alright, number 13. 13 is a square root of 112. Remember, you're looking to break these radical numbers up into two numbers where one of them is one of these perfect square root numbers. Because remember, square root of 4 is 2, square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, the square root of 49 is 7. So 112 is one of those weird ones. And then using your calculator, again, I would use your calculator to divide by 4, calculator to divide by 16, calculator to divide by 25. Try all these 5 numbers, and you'll see that 112 is 16 times 7. And then you could break that up into root 16 times root 7. And that gives you 4 times root 7. So those are a little trickier for sure. Number 14. 14 has you take the square root of 75x to the third. So again, take that 75 divided by 4, 75 divided by 16, 75 divided by 25. You'll see that 75 divided by 25 is 25 times 3. And then x squared, you want to get that power to be equal to that 2 that's out there. Remember that little hidden 2. So x to the third is x squared times x. So what you do there, you have two things that could be square rooted. That 25, split it up, you have that x squared, but then the 3 and the x cannot be square rooted. This ends up being a 5. X squared, square rooted, these cancel and just leave you x. And then these under here, you just rewrite those underneath the radical. So that's number 13. 14, I'm sorry, that was 14. 15. 15 is the square root of 120 over the square root of 5. So technically what they want you to do to get rid of that radical on 15, you need to multiply top and bottom by the square root of 5. What will happen here is you'll get the square root of 120 times the square root of 5 over the square root of 25. This becomes just plain old 5. So you have root 120 times root 5 over 5. And now I need to break that up. I need to find out what is in 120. So if I'm using my calculator, again, try to find all those numbers. Let's get rid of this. So I'm going to take 120, divide by 4. That gives me 4 times 30. I'm going to take 120 divided by 16, which is 7.5. 120 divided by 25. Nope. 120 divided by 36. Nope. 120 divided by 49. Nope. So it's going to be 120 divided by 4. It's 4 times 30. So what happens is I get 4 times 30. And then that root 4 and root 30 and root 5 over 5 gives me 2, the square root of 150. But now 150 has a perfect root in there too, and I got that by timesing. So 150 divided by 25 is 6. So that ends up being 2 times root 25 times 6. This is a complicated one, I know. Gives me 2 root 25 times root 6 over 5, which is 2 times 5 times root 6 over 5. These 5's will cancel, and you're left with 2 root 6. So that one was pretty lengthy. Be happy to help you with that one. Alright, 16. 16 even harder. So 16, I have the 5th root of 1024 x to the 3rd y to the 18. So what I need to do is try to find a number that times itself 5 times gives me 124, and that 1024, and that's going to be 4 to the 5th power. Because if you do 4 to the 5th power, that is 1024. So it's almost like you had to use this little root button on my calculator I'll let you use to fifth root that. So again, that gives you 4 to the fifth. And now what I do is I leave that x to the third alone. I need to break up this y. So that gives me y to the 15th times y to the 3. Because the fifth root is just going to divide right here and give you y to the third. So what happens is you get the fifth root of 4 to the fifth times the fifth root y to the 15th times the fifth root of x to the third times y to the third, because you can't do anything with them. These cancel away and give you 4. These divide out and give you y to the third, and then I just leave those alone underneath the radical. So those are pretty complicated, those radical ones. Alright, 17. Says solve the equation using any method of your choice. So 17, here it is, 17. 17 is 2x squared plus 8x equal negative 5. So I'm going to add 5 to both sides. And that gives me 2x squared plus 8x plus 5 equals 0. I'm going to do the factor method, x method first. So positive 8, positive 10. And I could see on that one, probably not going to have a number that gives me both those and adds to give me 8. So unfortunately, I have to use the quadratic formula. So x equals negative b plus minus the square root of b squared minus 4ac all over 2a, where a is 2, b is 8, c is positive 5 when I have everything on one side equal to 0. So if I plug those in, that gives me negative 8 plus minus the square root of 8 squared minus 4 times 2 times 5 all over 2 times 2. That gives me negative 8 plus minus the square root of 64 minus 40 over 4. 64 minus 40 is 24, so that gives me negative 8 plus minus the square root of 24 over 4. 24 is one of those perfect roots, so I'm going to break that up into 4 times 6 over 4. And then remember, when you split that up, that becomes 2 root 6. So I get negative 8 plus minus 2 root 6 over 4. And now these reduce. Divide that by 2, divide that by 2, divide that by 2. Gives me negative 4 plus minus root 6 over 2. Alright, number 18. I have x minus 6 squared equals 49. So I'm going to solve this one a little bit different. I'm going to solve for x by square rooting both sides. These will cancel out and leave you just x minus 6. And then root 49, you need to write that as plus minus 7. So that will break up into your two answers. One answer comes from solving x minus 6 equals 7. The other one comes from solving x minus 6 equals negative 7. So one of them I'm going to add 6, and that gives me x equals 13. The other one I'm going to add 6, and that gives me x equals negative 1. Those are both my answers. So 13 and negative 1. Alright, 19. I believe you're going to have to use the quadratic formula. Because if I have x squared plus 7x plus 3 equals 0, there is no combination that gives me 7 and 3 by timesing and multiplying. So quadratic formula, where this is a, b, c. So using that formula, negative b plus minus the square root of b squared minus 4ac all over 2a. Plug those in, gives me negative 7 plus minus the square root of 49. I'm sorry, jumping ahead there. So square root of 7 squared minus 4 times 1 times 3 all over 2 times 1 gives me negative 7 plus minus the square root of 49 minus 12 over 2, which gives me this negative 7 plus minus the square root of 37 over 2. So I leave that alone because there's nothing I could do to break up that 37 right there. Alright, 20. 20 has you use the quadratic formula again, but it's one of those ones you gotta watch out for, so I'll show you. When I plug in A, B, and C into this one, I get negative 5 plus minus the square root of 8 squared. I'm sorry, negative 5 squared minus 4 times 8 times 2 all over 2 times 8. And what happens here underneath the radical is you're going to get 5 plus minus the square root of 25 minus 4 times 8 is 32, and 32 times 2 is 64. This is going to give you a negative number. You cannot have a negative number underneath the radical. 25 minus 64 is negative 39. So you cannot solve that at this point using the quadratic formula. So at that point you would say no real solution. Whenever you have a negative underneath that radical, can't do anything with that. Alright, 21. 21, I'm going to make a little table like we've been doing to graph f of x equals 4x. So if you make a little table there, I'm going to have you use negative 2, negative 1, 0, 1, and 2. These are your x numbers. What you get after you plug them in and do the math are your y numbers. So when I plug in negative 2, I get 4 to the negative 2 power. I'm going to use my calculator. I would suggest doing that. So 4 raised to the negative 2 power, hopefully you can see that, gives me 0.0625, which is a very small number. When I plug in 4 to the negative 1, that gives me 0.25. 4 to the 0 is going to be 1. 4 to the 0 power, 1. When I plug in 1, it gives me 4. When I plug in 4 to the second, it gives me 16. So those are my coordinates to plot. Negative 2 for x, barely going up 6.25 for y. Negative 1 for x, going up a quarter for y. 0 for x, 1 for y. 1 for x, 4 for y. 2 for x, 16 for y. So when I graph that, a good representation will be, with this being the y-axis, x-axis, going up by 1s. Negative 2 for x, barely going up at all, 0.65. Negative 1 for x, going up a quarter. 0 for x, going up to 1. 1 for x, all the way up to 4. 2 for x is going to be way up off my graph even. So if I draw it, it has that exponential look. That starts off kind of flat and then shoots way up, but he's going to be looking for mainly those numbers right there. So that is 21. 22. Inverses. Alright, inverses are a little bit different, but what you do is you replace that with y. And then you do a switch. Where that y is, you put an x. And where that x used to be right there, you put a y. And then you solve this for y. Most people like to flip that around. So this is on the left side now, and that x is on the right. So my first step, I'm going to multiply both sides by 5. And that will give me 4y plus 1 equals, and I'm going to write that as 5x. Now I'm going to subtract 1 on both sides, and that gives me 4y equals 5x minus 1. And then right there I'm going to divide by 4. And that gives me y equals 5x minus 1 over 4. That is your inverse operation, or your inverse. So f of negative 1 of x is this, 5x minus 1 over 4. 23. Same thing, I'm going to find the inverse of that. So 23. I have f of x equals 6x plus 3. To find f of negative 1 of x, remember, do that trick again. Replace this with y. Put a 6x plus 1. Do the switch. That y becomes an x. That x right there becomes a y. Solve this for y. Flip it around so it's on the left side. A little bit easier for some people. Take away this 1 on both sides, and that gives you 6x equals x minus 1. Divide by 6. That's a y right there. Gives me y equals x minus 1. I'm sorry, that's x. Did I write the wrong problem? Oh, I'm sorry, Sabrie, that's a 3 right there. So that's a 3. That's a 3. That's a 3. Subtracting a 3. Sorry about that. Gives me y equals x minus 3 over 6. So that y, that is my f of negative 1. So I can just replace that at the end and just write that as x minus 3 over 6. 24, my logs. So logs are a little bit strange. If you remember the rules for logs, logarithms, this is your base. So you write that b. This is your exponent. So you write that number right here. And this number is your answer. So 2 log b 16 is the same as b to the second power equals 16. So if you wanted to solve that, you would square root both sides, and b equals 4. So really that answer is 2 equals log base 4 of 16. That is a true statement right there. But they just want that right there. They want you to write that in equivalent exponential form. That's equivalent. B squared equals 16. That's its equivalence. Alright, 25. Same kind of thing. 25. 7 x equals 343. Now I do it the opposite. So I know it's going to be some log. The base number goes right here, the answer goes right here, and the exponent goes right here. So this is the exponent, so that goes right here. The base goes underneath here, and then the answer goes right there. So that is x equals log base 7, 343. I know that's a little confusing, those logs, but I'll be happy to help you. All right, 26. For this one, you have log base root or base 10, 13. He wants you to do that on your calculator. So on your calculator, you're going to do it like this. You're going to do the log of that first number right there, which is 13, over a log of the base, which is log 10. So you're going to do that on your calculator using this log button. I'll have you use my calculator. So this is your log button right here is my log button. So I hit log 13 and then I close that parenthesis, divided by log 10, close that parenthesis, and that gives me 1.113, and it says round it to 4 decimal places. So 1, 2, 3, 4. The number next to it is 4, so that rounding number stays the same. So that becomes 1.1139. All right, next one is log with base 0.819. So you do it the same way. Log 19 divided by log 0.8 on your calculator. So here I go. Clear that. So log 19, close that, divided by log 0.8. Round to 4 decimal places. So 1, 2, 3, 4. That's going to round up to a 3 because the number next to it is 5 or more. So that gives me negative 13.1953. All right, what do we got next? 28 and 29. I'm probably going to stop right there. This will be part 1. Maybe try 30. I got to draw 30. All right, let's just go all the way through. So 28. I have the formula A equals P times 1 plus R to the N over NT. So I'm going to type that in exactly, where P is my principal. So I put 650 right here times 1 plus R is my rate. So that is 6% as a decimal, which is 0.06. N is my number annually, so annually is once a year, I believe. And then I do 1 because it's annually once a year times 8. So I'm going to type that in exactly on my calculator. So I got 650 parenthesis 1 plus 0.06 divided by 1. Close that. Raised to the 1 times 8 power, and that gives me a different number than the key. So I'm going to pause this and see what happened there. Alright, so I'm not sure what happened there. I'm going to do that again. My calculator, it worked this time, so I'm going to try that exactly. So annually is 1, so 650 parenthesis 1 plus 0.06, 6%, divided by 1 annually, and that raised to the 1 times 8, which is 8 power, gives me 1036. So that's that right there. Type that in exactly on your calculator. Hopefully you can see that. Alright, 29. So compounded quarterly means 4 times a year. So it says find out how long it takes to double its investment, round to the nearest tenth. So this one I'm solving for t. Alright, so it says how long to double. So 2,500 times 2 means this is going to be 5,000 equals the amount of money I'm putting in, 2,500 times 1 plus the rate, which is 0.09, over quarterly, which is 4, times 4t. So I'm solving that for t right there. Let's see. So I'm going to divide both sides by 2,500. That gives me 2 equals 1 plus 0.09 over 4 to the 4t power. Let's see, what do I do there? Alright, 29, I'm going to have to get back to you on 29. I'm not 100% sure. I'm going to have to see what I need to do on that one. But I know I can do number 30. Let's open that up. Okay, I'm going to pause this to try to draw that. So I'm going to use this diagram here. So if you remember, there's 4 intersections or 3 intersections. What's coming in, this 300 and this 200, is equal to what's coming out. So this is x2 and x1 coming out. So that first equation at A is this 300 plus this 200. Those are coming in. So 200 plus 300 equals what's coming out, x1 plus x2. That's what's coming out of that intersection. So that's at intersection A. 200 plus 300 equals x1 plus x2. At intersection B, I have x2 coming in and 50 coming in. And what I have coming out is 100 and x3. So coming in this intersection, x2 plus 50, and what's coming out is 100 plus x3. C, I have coming in x3 and x1, and coming out I have 200 and 250. So again, what's coming in? These two coming in together, x3 and x1. What's coming out? 200 plus 250. So that is part A. Part A has you just write the equations, which are A is 500 equals x1 plus x2. B is x2 plus 50 equals 100 plus x3. And C is x1 plus x3 equals 450. So that is the answer to A right there. He wants you to write those equations right there. Part B has you plug in x2 is 200 and try to find the other variables. So when I plug in 200 right here, which is x2, I get 500 equals x1 plus 200. So if I take away 200, that will give me what x1 has to be. So x1 has to be 300. So now all I need to do is find one more, because I have 2 of them. I have x2, x1. Now to find x3, I'm just going to take this and plug it in right there and solve for x3. So x1 plus 300 equals 450 minus 300 gives me x1 equals 150. So those are my three answers. Alright, we'll take a look at that 29 and I'll get back to you on that one. And then hopefully this plus the combination of the first ones will be able to help you out a little bit before we meet again. Good luck.